My company is called Verbos Electronics, and we've been around for about 5 years. The new stuff that we're showing this year are, well, primarily already at the NAMM show in California, we introduced the Mini Horse, which is this touch plate controller right here, and the control voltage processor. And we also, less interesting, but we also started making our cables not just in gray, but the short length in red, the medium length in gray, and the long ones in 1 meter long ones in black. At Superbooth this year, we have a new wooden skiff case that's a lot like this one. This one was made in New York. We just the other night picked up the first new one that's made here in Berlin, and it has beautiful craftsmanship, but about an hour ago in here I blew it up somehow, so I'm not showing it here. And we intend to start offering complete systems for the users who have been asking for that. And along with the complete systems, we are showing the new amplitude and tone controller, or amp and tone as we've been calling it, which is right here. The original one that we've had since we started the company 5 years ago is 16 HP, and this is 10 HP, so we're starting to run out of space here, so we were cramming together more into a smaller space. And the functions are all the same, but the Vactrol-based low-pass filter has been changed to be all discrete transistors, eliminating a part that is no longer available, and what is available, the clones of it, are not so great. So this is the direction that I feel we're going to go with it. So firstly, for this demonstration, I'd like to talk about the Mini Horse. So it is a 12-key touch plate keyboard controller that each key has positional information, that is where you're touching on the key, pressure information, which is how much of your finger is touching the key, and a gate output. And all of those keys are operating independently. So if you press multiple keys at the same time, they're not going to interact with each other, which allows it to be used not just as the touch plate keyboard for playing different pitches as you go across the keyboard, but also as a polyphonic controller or a touch-based slider box or something like that. So as a first example, right now we have a patch going that shows the pressure outputs from the first 8 keys plugged into the CV inputs on the mixer section of a harmonic oscillator. But also these can be patched into the position outputs, and what's nice about that is we can effectively draw the harmonic line. Wherever you last touched the key in position, it will hold infinitely. And in this case, the positional outputs are controlling a whole bunch of parameters that are related to each other, but there's nothing actually stopping the stopping it from being used with 12 totally unrelated parameters like the pitch, filter cutoff, amplitude, whatever, all in a row, or each individual key being used as its own voice. A really quick example of that. And also in combination, so the patch that I had before. Tunable keys in the style of the Buchla keyboards from the 60s. And there's a fixed spacing output from the keys. Which, because they're across 10 volts, equally spaced, maybe that's not useful for pitch unless for experimental purposes, but it can be used, for instance, to patch keyboard tracking on a filter or some other parameter that you would want to change as you go across the keyboard, perhaps using the knobs to tune the individual notes. The second module, which we have patched in right now, is the control voltage processor. The two lower sections are voltage mixers that can have two channels with reversing attenuators or attenuverters, and then a voltage-controlled crossfader, which can be used in addition to crossfading between two different signals. It can be treated like a VCA that opens with more voltage, or one that closes with more voltage, and then finally an offset. So that can do inverting, scaling, multiplying, dividing, offsetting. And then the top section is a voltage-controlled slew generator with separate positive and negative going slopes with voltage control, which is, of course, familiar to everybody from so many of the existing modules, like the Surge DSG or the Maths or whatever. But the couple of unique features in this case, the shape is continuously variable. from a linear ramp to a true RC curve, which means that the attacks are always convex and the decays are always concave, and it doesn't use feedback, so this operates over the entire range of voltages from all the way to the negative rail to all the way to the positive rail, and always functions in a rational way where the curve is the same shape. And the bounce feature. So what happens is that the bounce is a bit like, if you consider the slew generator or slew limiter to be essentially a low-pass filter that's dealing in a really low frequency range, bounce is effectively like turning up the resonance. So as the CV approaches the destination, so if you go from here to here, you have the ability to slow it down, but as it approaches the destination, it overshoots by an amount related to the bounce control and then wobbles down. So when that is done with when that's done with a CV, it actually will, excuse me. It actually creates a bit of a wobble on the attack. It's a bit like the sound of a string being plucked. And this can be effective for getting away from the firm, rigid CV sequences, mechanically flat on each pitch, but actually bending around more like acoustic sounds that have a little bit of variation within the notes. To perceive it, maybe. Thing I'd like to show is I'm gonna tweak the new amp and tone a little bit and show some of the distortion and balancing and tone shaping characteristics that this module historically has been known to make it special. Thank you.